Hi everyone, I hope it's going okay. This is our second lesson of our second unit. So you may be just doing this right after you did the first lesson. If not, you probably want to do a little review of completing the square, which we talked about in the first lesson. And so today we're going to continue on with that idea, only we're going to look at better ways, or quicker ways I should say, of finding the vertex. But first let's go through completing the square. If you just did this, you can probably skip this part. But if it was a little while ago, you probably want to watch over. There is a little bit of a trick in this one. So remember when completing the square, we group the x terms. So I just put them in a bracket together. Then I factor the a value regardless of what it is. So I take it out. So remember, if I'm factoring is the same as division. So if you divide something by 1/2, it actually multiplies the number by 2. So this becomes negative 2x. And the reason is because if I have 1 here and I divide it by 1/2. So remember division with fractions, we always take the fraction and we flip it. So it becomes 1 times 2, which becomes 2. So this one was negative, so I have it as negative 2. So the next step is that weird thing where we do half of the b term and square it. So half of negative 2. And then I square that. So that becomes negative 1 squared. Negative 1 times negative 1 is just 1. So I add and subtract that number inside the bracket. So that creates our perfect square. But we don't want the negative term in there because that's not part of the perfect square. So I pull it outside. So when I pull it outside, I have to multiply it by whatever I factored out, the a value here, which is 1/2. So I get minus 1/2. So then I can do my last steps together if I want. So I factor this guy. So this becomes half of the b. So that becomes minus 1 squared. And then outside I add those together so I get plus 1/2. So therefore my vertex is 1, 1/2. And we're done. So again, a process you need to know for the test, and it also is useful because it gets you the vertex. But we will see today there's different ways to get the vertex. So a couple things to go through, kind of just to review, but we're bringing this all together. So it says I've got my axis of symmetry in what we call as the optimal value. So the axis of symmetry relates, remember that's the red dotted thing here. So it's the thing that splits our parabola directly in half into mirror images, left and right. And so that's the x coordinate. So my axis of symmetry is this guy. So that's my AOS. So the middle part. And that gives me the x value of that. The y coordinate we often call the optimal value. And the reason because it's going to be the optimal highest or optimal lowest value. And so we're going to look at some problems eventually where we have optimization. So we want to find the highest and lowest stuff in which we have a maximum or possibly a minimum. And so that's always going to occur, of course, at the vertex. So to determine if the optimal value is a max or min, we need to look at, remember, the a value in front, which indicates my direction of opening. So is it opening up or opening down? I gave you this little graphic here on the right where I've got smiley face, sad face, and that tells me which way it's going. So the a value comes from this in front of my vertex form. So a there. So this guy. So just to remind you, if a is greater than 0, I've got happy face, which gives me a minimum. And if a is less than 0, sad, and I get a max. So maximum value. So our vertex we can think of, really it's going to be my axis of symmetry for x, my optimal value is the y. So we can easily find the axis of symmetry. Remember we talked about that, but Once we know the axis of symmetry, we can then sub it back in order to find the optimal value. And that's the kind of method we're going to use today. So we actually covered this in the last unit, but if you were in factored form of your quadratic, so remember my factored form, y equals a, I think we called it R and S. If I had them like that, I could find the axis of symmetry. So the x value, so my axis of symmetry for my vertex, was going to be the average of those two. So I add them together and I divide by 2. And so my axis of symmetry is R plus S divided by 2. And if I had that, I could just then sub that back in to find. So like, for example, this one, if I had y equals 2, x plus 3, x minus 5, my roots, if I solve them, x equals negative 3, so I switch the sign, and x equals positive 5. So my axis of symmetry, i.e. the x value of my vertex, is going to be those two numbers divided by 2. Added together, divided by 2. So if I do that, I get negative 3 plus 5 is 2. 2 divided by 2 gives me 1. So therefore, the x value of the vertex, you could call it h if you want, it's up to you. So that was one way we did it in the last unit. But what if the equation is in the standard form? So remember, standard form is the ax squared plus bx plus c. Then we can find the axis of symmetry by doing something else. And you may remember this. So if you look at my quadratic formula, it's actually related to that. So here's my quadratic formula. And we already used the part underneath the square root. That was the discriminant. Remember, that told us how many x-intercepts there are. But this part here, the negative b divided by 2a, actually tells us the axis of symmetry. So another way to get it, if you're in the standard form, is going to be negative b over the 2a. And so it's this nice, simple process, especially because often you're in the standard form. So if it's in standard form, you can just simply take the negative b and divide it by 2a, and that gives you your axis of symmetry. So it says find the axis of symmetry in this example for the following function. So remember, here is my a, here's my b, and this is c, and we don't even really need c in this one, but I'll identify it. So my axis of symmetry is negative b divided by 2a. So I have negative 12 over 2 times negative 3. So negative 12 over negative 6, which obviously just becomes 2. So therefore my x equals 2 at the vertex. So if we wanted to find the optimum value or the y value, I just simply sub that back in to my equation. So let's try this in a question here. So finding the optimal value, so I've got this. So first thing to identify, so I'm looking at this guy here. What form are we in? So hopefully you recognize instantly that this is my standard form for my quadratic. So I've got that. So the first step, and it's listed over here, is find the axis of symmetry. So I know that that is negative b over 2a. So negative b becomes negative of negative 8. You could just switch that to 8 if you want. Over 2 times a, which is 2 times 2. So I end up with 8 over 4. So obviously that is 2. And so that gives me my x value for my vertex. But what they're asking for here is the optimal value. So now I find my optimal value. And I do that by just simply subbing back in. So sub x equals 2, the axis of symmetry, back into the equation. So I've got y equals 2 bracket 2 squared. And plug it in wherever you see x. So you've got this little algebra problem to solve. So 2 squared is 4 times 2 is 8. Negative 8 times 2 is negative 16. and plus 11. And I just put those together, so I guess that's going to become, is that the right number? Yeah, plus 11. So that's negative 8 plus 11 is going to be 3. So therefore, my vertex is 2, 3. And if I was solving my optimal value, which they asked for, it's 3. And if you wanted to, you could even determine if it was a minimum or maximum. Because my A value is a positive 2, I know that this is going to be a minimum because it's opening up. So great. So you've got all these different ways to find the axis of symmetry or the vertex. So, you can always do the same thing by completing the square. And in a question, I will ask you at least once to use the method of completing the square on a test, but you can also just find by doing the other way. So this one says find the optimal value by completing the square. It's the exact same numbers as above, but let's just go through it quickly. So I group the x terms, factor my A value, add and subtract half of b squared. So I'm going to add and subtract, forgot my squareds. Half of 4 squared is 4, so I had plus and minus 4 inside. Go through that. Pull out the negative 1. So that becomes negative 4 times 2, which becomes negative 8. And then I end up with half of the b goes in there, so negative 4 divided by 2. And then outside I've got plus 3. So again, I get the same thing as above, so I have a vertex of 2, 3. And my optimal value obviously is 3 again. Okay, so 2 different methods. If you compare these, the numbers are pretty easy to complete the square, but generally using the optimal value way where you have the axis of symmetry is a bit easier, less work, I think, a bit more efficient. But you can be the judge. Okay. So it says using your preferred method, solve for the optimal value of the following functions. So you could try this. So I would pause the video here and see if you can get these. So you want the optimal value, so not just the axis of symmetry. So you can go through these steps. So pause the video now and then check your answers. So this one, we get some not such nice numbers, but because 4 divided by 3 becomes 1.3333 repeated, it's better to leave it as a fraction. Otherwise, you're not going to get a correct or accurate answer at the end. So if I go through that, so you're probably going to want to use your calculator. So this becomes 16 over 9 times 3 becomes negative 16 over 3. This one I just multiply the tops. Is it negative 8? Oh, I forgot the negative right there. So that becomes positive 32 over 3. And then at the same time, I'm going to change negative 15. Notice how I've got these two denominators of 3. I'm going to change negative 15 to over 3. So that means I multiply the top and the bottom by 3, I think. Is it negative 15? Oh, 35. Oops, I copied it down wrong. Like that. So if I multiply the top and bottom by 3, I get negative 105 over 3. So now I can simply just add all the numerators together. Notice 2 of them are negative though. So if you do that, you end up with negative 89 over 3. So that one, the numbers are a bit tricky to work with. So therefore, the optimal values, or the optimal value rather, singular, is negative 89 over 3. And I can leave it just like that because I don't want a repeating decimal. And you can determine if it's a minimum or maximum, and you do that by looking at the a value. So this is a negative. So remember, a negative goes like that. So I get a maximum value up here. And if I go back to a, similarly, I've got a positive value, and so this is a minimum. Like that. Okay, the next one, we can do this one together if you want. This one says, it's very similar to what we had in the first unit. A ball is shot from a cannon into the air. Equation that gives the height h in meters of the ball at any time t in seconds is this. So h equals this thing. At what time did the cannon reach its maximum height? I think it should be cannon ball reaches maximum height. If I do that, so remember before we would have to find the roots and add them together, divide by 2, but now all I have to do is do the axis of symmetry, which is negative b over 2a. Again, I can do that because this is my standard form. So if I have negative b, that's negative 32 over 2 times a, which is negative 16 times 2. So this just becomes 1. So this is the time, the axis of symmetry representing, in this case, t instead of x, because t is my independent variable. And so my time is 1. And it says at what time did the ball reach its maximum height? So that's it. That's all I needed. Therefore, the ball reached the max height when t equals 1 and we're in seconds. That's it. Now the next part is the second part where we want to find the optimal value. So it says find the maximum height. And notice my a value, if I go back here, this is a negative 16, so I know it's going to be a maximum. So my optimal value, or my max or min, whatever you want to call it, I just simply sub t equals 1. So I've got h equals negative 16 times 1 squared plus 32 times 1 plus 1. So you can go through those steps. Negative 16 plus 32 plus 1. So I end up with h, my height, in 17. So therefore, the maximum height is 17, and we're in meters, I think, yeah. And that's it. So something that was a much harder, if I was to try to figure that out going to factored form, that's going to be a lot more work because I'd have to use a quadratic formula and then blah, blah, blah. Just much easier to do it this way. Okay, try out the next ones. You may need some help, but really you're always, in this case, if you're looking for the max and you've got something in standard form, you just need your axis of symmetry and the optimal value. Just watch out. I think part C throws a curveball in because it goes back to what we were doing in the last unit. So try these out. I'm going to put the answers up so you can check them. And I'll put them up if you want to. I'll write them down right now so you can pause the video and check your answers. Or you can go to OneNote and stop the video. Okay. So in part C here, just watch, you've got to solve for x in this case because we're looking for when it breaks even. So that means the profit is equal to 0. And so in this case, I end up with two answers after I factor it of 5 and 9. And the reason is because we have something like this. So if this is 5 and this is 9, maybe I'll move this over a little bit. I've got something where my profit breaks even. So it goes up and then comes back down. The reason is often, if there's this point, if you overproduce whatever your product is, in this case, the games, then you start to lose money at some point. And so you max out at some certain level. We could easily figure that out. We had it up here, which was 7. So 700,000 games. And so in this case, we break even at 2 points. So the first one is because you have all these startup costs. When we produce 5 and 900,000 games. Like that. Okay, so there's the answers to those. And so you can go on to these questions listed below. Okay, if you haven't